Bismillahirrahmanirrahim. Let's start this November 2020 uh, paper 51. That is a paper of statistics and probability. Okay, so here we are. Let us start this. Pehla question. Okay, it says two ordinary fair dice, one red, another blue, are thrown. Even A is the score on the red die is divisible by 3, and even B is the sum of the two scores is at least 9. Okay, so we should try to make a table diagram for this. This will make our work easier. Okay, so here is a red die. This is 1, 2, 3, 4, 5, 6. And then there is a blue die. Okay, so this has 1, 2, 3, 4, 5, 6. Okay, it says even A is the even A is the one where the red die is the score on the red die is divisible by 3. Okay, so divisible by 3. So I can write here, this is your A, this is your A, 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 because 3 is divisible by 3. So all of these are showing A. This is going to be A as well. Okay, so these are the 6 A's here. Even B is sum of the two scores is at least 9. The sum is at least 9. Okay, now at least 9. So with 3, if you have 6, so here the sum is, I'm going to write A slash B. Okay, with the 4, if you have 5, so the sum is going to be 9. Enough? With the 5, if you have 4, the sum is 9. If you have 5, you have the sum is 9. Okay, and I should write here slash b as well, because 4 plus 6 is 10, 5 plus 6 is going to be 11, so this is b as well. 6 plus 3 is going to give us 9. 6 plus 4 is 10, 6 plus 5 is 11, 6 plus 6 is 12. Okay, you can see that there were 6 plus 6, 12 times we have A, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 times we have B. And he's asking for the probability of A and B. So this is going to be 1, 2, 3, 4, 5. There are 5 such cases out of these 36 where we have both A and B happening. So through this straight table diagram, we have found this probability of A and B, that is going to be 5 over 36. I will check the answer. Yeah, this is 5 over 36. Okay. Next, it says, hence determine whether or not the events A and B are independent. So when you have two independent events, Bacho, if two events are independent, then the probability of A and B should be equal to probability of A times probability of B. So let us check that if this is really happening here. Probability of A and B we just found, that is 5 over 36. Now, is that really equal to probability of A, that is 12 over 36, times probability of B is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
10 over 36.
10 over 36, yeah. So this is 10 over 36. So I'll go down here. So that is going to be, okay, so yeah, this is going to be 10 over 36. So they are clearly not equal to each other. Therefore, A and B are not independent. Let me ask you one more question from here. Are these two events A and B, are these mutually exclusive or not? Hmm? How do you determine if two events are mutually exclusive or not? Hmm? Anyone? How do we know if two events are mutually exclusive? If,
So the probability of A and B is equals to 0.
yeah, it has to be equal to 0. So this is equal to 5 over 36. So this is not equal to 0. So this means they are not mutually exclusive. So you must be familiar with these terms, the mutually exclusive and the independent events. Okay? Let's move on to the next question. It says the probability that a student at a large music college plays in the band is zero point 0.6. Okay? For a student who plays in the band, the probability that she also sings in the choir is zero point 0.3. For a student who does not play in the band, the probability that she sings in the choir is X. Acha, so this means I need to have a tree diagram here. First of all, um, it is going to be plays or does not play. So plays, there is probability zero point 0.6. So this probability will be zero point 0.4. And for a student who plays the band, probability that she also sings. So uh, sings does not sing. So this is zero point 0.3. So this has to be zero point 0.7. And for the student who does not play in the band, the probability that she sings is X. So here, sings, that is X, and does not sing, that will be 1 minus X. Please remember this. The sum of the probabilities on these branches has to be 1. Acha, it says the probability that a randomly chosen student from the college does not sing in the choir is 0.58. So the probability does not sing, that is going to be 0.58. Now, this singing or not singing is dependent on playing or not playing. So we can't just find probability of not singing. We'll have to write it like this: the probability of playing and not singing, or not playing and then not singing, that is basically equal to 0.58. So playing and not singing, that is zero point 0.6 times zero point 0.7, that is 0.42, plus not playing, not singing, that is zero point 0.4 into 1 minus x, that is equal to 0.58. You solve this equation carefully, don't make any silly mistake. 0.58 minus 0.42 is going to be 0.16, and then 1 minus x is going to be 0.16 divided by zero point 0.4 is going to be zero point 0.4, and your x is going to be 1 minus zero point 0.4, that is equal to zero point 0.6.
Point 6.
Quickly confirming the answer. Where is that? Yeah, here your x is zero point 0.6. Okay? Okay, so this answer is correct. Now let's go to the B part. It says two students from the college are chosen at random. Find the probability that both students play in the band and both sing in the choir. Play and sing, and there are two students. So this would be probability play and sing and play and sing. So this should be playing and singing is zero point 0.6 into zero point 0.3, and and zero point 0.6 into zero point 0.3. Okay, so this should give us the answer. That is part B's answer. Okay, so what is this answer, bacho? 0.18 square, that is 0.0324 है ना, that is 0.0320. Oh, you know, these people enter and everything is messed. 0.0324, and we should check the answer. Yeah, this is 0.0324. Okay, so this was your third question. Sorry, second question. So we are on to the third question. Okay. Now in this third question it says, um, Kayla is competing in a throwing event. A throw is counted as a success if the distance achieved is greater than 30 meters. The probability that Kayla will achieve a success on any throw is 0.25. Find the probability that Kayla takes more than 6 throws to achieve a success. Okay. Now, is this a geometric distribution or a binomial distribution? Please tell me quickly. Hmm?
Geometric.
Yeah, because we are just going to see that when do we have the first success. So it says, so let's write it as that x is geometrically distributed, the probability of success that is 0.25. And we have to find the probability that x is more than 6. X is more than 6. Okay. So this means that it is going to be q raised to power 6. We are quite sure that he is not going to be successful in the first 6 throws because it says takes more than 6 throws to achieve a success. Okay, so this should be 0.75 raised to power 6. And you can write your answer. You can leave it this way because this is very big power. If you have any question, you should let me know. Look at the B part. Find the probability that for a random sample of 10 throws, Kayla achieves at least 3 successes. Now this is clearly a binomial distribution because it says out of 10 throws, that is your n, at least throw 3 successes, that is your r is greater than or equal to 3. Okay, so I'll be writing it like this. Okay, now I'll say that let x is binomially distributed with 10 and this 0.25 as the probability of success. And now we will find the probability that x is more than or equal to 3, at least 3. So if you go from 3 onwards, there will be a lot of working to be done. So let's do it this way. 1 minus probability x is less than 3. So this is going to be 1 minus probability x equal to 0 plus probability x equal to 1 plus the probability x equal to 2. So this is going to be 1 minus 10C 0.25 raised to power 0 into 0.75 raised to power 10 plus 10C1 into 0.25 raised to power 1 into 0.75 raised to power 9 plus 10C2 into 0.25 square 0.75 raised to power 8. This will give you the correct answer. This is 0.474. After using the calculator, you get 0.474. You have to ask me if there is any problem. Your silence means that people are understanding all of this.
सर
Yes, beta?
सर ये पार्ट प्लीज फिर से एक्सप्लेन कर दें
Yeah, what do you want to ask from here? Yeah, what is the problem with this?
सर ये when you did this 1 minus p into x is equal to 0 वहाँ से
But the thing is, when you define the probability that there are at least 3 successes, so beta, one way of doing is that you write it like this: probability x equal to 3 plus probability x equal to 4 plus probability x equal to 5 plus probability x equal to 6 plus probability x equal to 7 plus probability x equal to 8 plus probability x equal to 9 plus probability x equal to 10. Now, finding all of these, is that easier, or doing 1 minus the complement of this, is that easier? Hurry up. Hello. Okay, the person who asked the question has died, unfortunately. So we are going to move to the next question. Who was that asking this question?
सॉरी सर इट्स क्लियर समझ आ गई है
Okay. You should be alert, yeah. This the class is going on. Okay. Question number 4. The random variable x takes each of the values 1, 2, 3, 4 with probability 1 over 4. Two independent values of x are chosen at random. If the two values of x are the same, the random variable y takes that value. Otherwise, the value of y is larger value of x minus the smaller value of x. Now, once again, if you people have a table diagram, your life would be easier. Okay. So this is your 1, 2, 3, 4. And then you have here 1, 2, 3, 4. Acha, it says if the two values of x are the same, the y is going to be the same. So, bacho, this is going to be 1, 2, 3, 4. These are the values of y because this is 1, 1, 2, 2, 3, 3, and 4, 4. Otherwise, this is going to be the larger minus the smaller. So, bacho, this is 2 and this is 1. This is going to be 2 minus 1, 1. 3 minus 1 is 2. 4 minus 1 is 3. Now, this one is 3 minus 2 is 1. This is 2 minus 1 is 1. 3 minus 1 is 2. 4 minus 1 is 3. 3 minus 2 is 1. 4 minus 2 is 2. 4 minus 3 is 1. 4 minus 2 is 2. And 4 minus 3 is 1. So these are, bacho, these are the values that y can take. So let's have the probability distribution. This is y, probability y equal to y. This is, it can be 1, it can be 2, it can be 3, it can be 4. So, मेरे बच्चों, this is 1, 2, 3, 4, 5, 6, 7. There are 7 ones, 7 over 16. 2, 1, 2, 3, 4, 5. This is 5 over 16. Threes, 1, 2, 3. This is 3 over 16. And this one is 1 over 16. So this is the probability distribution. You see, you people are getting you get 4 marks for this. If you have any question, you should let me know. And if you people are trying this while I'm doing it, that would be the great thing to be done because only then you can understand what is happening here. Acha. Next it says find the probability that y is 2 given that y is even. Okay. So we will find probability 2 given even. Okay, 2 given even. So this can be probability of 2 and even divided by probability of even. Now 2 and even, this is 1, 2, 3, 4, 5. So this is 5 over 16. And probability of even is going to be 1, 2, 3, 4, 5, and there is this 6 as well. So it's going to be 6 over 16. So your answer is 5 over 6. Let me check the answer. Um, yeah, this is 5 over 6. That is the right answer. Okay? If you have any question, please, you can ask that question. Otherwise, I'm going to move ahead. Question number 5. Okay, the time in hours that Devin plays on his game machine each day is normally distributed with mean, this, and standard deviation. But so you must have your calculators and your normal distribution table with you. So this is x is normally distributed with the mean 3.5 and the standard deviation is zero point 0.9. So I should write a square on it because we mentioned the variance here. Find the probability that on a randomly chosen day, Devin plays on his game machine for more than 4.2 hours. So we have to find the probability that x is more than 4.2. Okay, more than 4.2. So we can straight away go for the standardization. This is z is greater than 4.2 minus the mean over the standard deviation. That is zero point 0.9. Okay, that is probability z is greater than 4.2 minus 3.5 is 0.7 over 0.9. That is 7 over 9. And this will be 1 minus phi of 7 over 9 is that 0.778, Anna?
जी sir, 0.778.
So 1 minus, let's see what is phi of 0.778. 0.778. 0.778 That is 7794 plus 21. 0.7795 है ना? 0.7795. 0.7795. So this is going to be 0.2205. Let me check the answer. Question number.
Sir, 0.7815 नहीं होगा.
Oh, sorry. 0.781. Oh, yeah, I made that mistake. 0.7818. So this is going to be, yeah, thank you, beta. This 0.218. Okay, so this is your answer for this A part. Let's go to the B part quickly. It says on 90% of days, Devin plays on his game machine for more than T hours. For more than T hours. Okay. Now just keep this answer noted. That is point. Let me write it here because this will be used in the next part. Probability x is more than 4.2 is 0.218. So now he's saying, he's giving us that more than t hours, the probability is going to be 90%. So we have to find this t. Okay, so I'll be writing it like this, that okay, we still have the same normal distribution. So probability x is more than t, that is going to be zero point 0.9. 0.90. We standardize this. Probability z is greater than t minus 3.5 over zero point 0.9. That is equal to zero point 0.9. Now, so there is a problem over here. You have the greater than sign and the probability is more than zero point 0.5. This means that this value over here has to be a negative value. So you have to make it negative. You have to try to make it negative. So let's write it like this. Probability z is greater than, I'll take a minus common from here. That is 3.5 minus t over zero point 0.9. That is equal to 0.9. Now the things are going to be fine because you know that probability of z is greater than minus a is simply going to be replaced with phi of a. So this is your phi of 3.5 minus t over zero point 0.9, that is equal to 0.90. So this 3.5 minus t over zero point 0.9, that is equal to phi inverse of zero point 0.9. This is 3.5 minus t over zero point 0.9. Now let's go to the table again. I can go down here and here I have the critical values. The probability is zero point 0.9. Look at this, I'm using this one. Okay. So z is going to be 1.282. You can use these critical values as well. This is going to be 1.282. 1.282. Going to go back to the paper. So now using the calculator, you will have this 3.5 minus t is 1.282 times zero point 0.9 and your t is 3.5 minus 1.282 times zero point 0.9 and this should be, I can see the answer from here, this should be 2.35. This is 2.35. This is the time, these many hours is going to play. Okay, more than these many hours. This is your t over here. Okay, now let's go on to the, if you don't have any question here, I should be moving on to the next part. It says calculate an estimate of the number of days in a year on which Devin plays on his game machine for between 2.8 and 4.2 hours. 2.8 and 4.2 hours. Acha bachcho, the thing is, let me tell you first of all, please let me write x was normally distributed. Iska mean was 3.5 and the variance was zero point 0.9 square. Na? So now we've given, we'll find basically that x is between 2.8. You will find this probability and then you will multiply this probability by 365. You will get the number of days, because in any day, playing for these many hours, between these many hours, uh, that will be calculated this way. Okay, so let's do that. This is, I'll be standardizing it. Z is going to be between 2.8 minus 3.5 over zero point 0.9, and this is 4.2 minus 3.5 over zero point 0.9. Acha, when you simplify this, you get probability Z is between minus 7 over 9, and this is 7 over 9. So you can write it as phi of 7 over 9 minus phi of minus 7 over 9. Remember, phi of minus A is, phi of minus A is 1 minus phi of A, and minus phi of minus A is going to be phi of A minus 1. So this way this becomes 2 phi of, we know that this is 0.778 minus 1, and you have already calculated this. What was this answer, yaar? I just um, erased that. Hmm? What was phi of 0.778?
Sir, it was 0.7815.
7818.
15. 5 था सर, आपने गलती से 8 लिख दिया था.
Basically this has to be correct to two decimal places now, so let's write it like this, minus 1. So now let's find that. What is this going to be? 2 into 0.7
0.564.
minus 1.564, and then you multiply this with 365. So the answer is going to be expected number of days, है ना? That is just 0.564 times 365. That is 206 days, approximately 206 days. Oh, okay. Let's confirm the answer. Okay, this is uh, 205.7. So that is, he's writing this 205. Hmm? Okay, so this is going to be 205.
सर उन्होंने कहा हुआ except 205 or 206.
Uh, mm, what did he say?
सर वो साथ वाले बॉक्स में लिखा हुआ था उसने कि except 205 or 206.
चलो ठीक है, फिर we are happy then, our answer is right then. Okay, so this was the C part. Now we are on to the question number 6. We shall do the question number 6 and 7 in the next segment. Okay, so I'm going to finish this here. So see you back in the next session for the last two questions.